Since 1990, Mission Support Incorporated, or MSI, has pioneered the combination of sheet metal fabrication and modern CAD/CAM dimensioning technology for improved production capabilities. MSI overhauls and manufactures airframe subassemblies, structural components, flight controls, and other associated actuation systems for the Department of Defense. Based in Clearfield, Utah, MSI has been a leader and innovator in the implementation of real-time CAD/CAM digital manufacturing and inspection of U.S. Air Force legacy aircraft components. Most recently, MSI was contracted by the U.S. Air Force to overhaul the engine bypass ducts on the B-52 Stratofortress bombers. The Air Force made the decision that the B-52 was to be kept in service for 3 more decades, until 2042. Despite the adversities it would face in the rebuilding of these components, MSI was up to the challenge. The most difficult issue was the lack of adequate technical data. Most of these aircraft engine ducts have been in operation for over 30 years, and many are misshapen, corroded, or distorted, and using the original hard tooling to rebuild them proved to be a non-viable option. Increasing reports of fit problems from the field showed the need for a better solution. Richard Hansen, Quality Assurance Manager at Mission Support, supervised the B-52 bypass duct project.
When we first started the contract, we were only required to do certain aspects of the overhaul for this contract. There were a lot of fit problems, and mainly due to there was a lack of technical data, there was a lack of fixtures, there was a lot of upstream and downstream tooling that originally was used by Boeing that we never possessed.
MSI decided that the best solution was to essentially remanufacture the bypass ducts by performing a complete disassembly and reassembly.
We decided we would reverse engineer the ducts and create CAD models of them. And we were able to get a hold of the original Boeing master molds, the original Mylars, the original drawings, and it was really kind of a puzzle process.
Utilizing the FaroArm with Verisurf CAD software in reverse engineering mode, MSI generated point cloud profiles of the old master molds. Combining these point clouds with data from existing tool drawings, MSI produced 3D CAD solid models for all 6 duct configurations. MSI then calibrated the original assembly fixtures and revamped manufacturing of the ducts themselves, incorporating CAD/CAM technology at every level of their production process. To improve the dimensional accuracy of the placement of these piece parts reattached to the ducts, MSI production personnel located every geometric point using the FaroArm. Eventually, they developed a number of production techniques using the FaroArm as a virtual tool in the production process to rebuild these engine ducts. MSI now uses a FaroArm for both their production and quality assurance inspection needs. Using the FaroArm hardware and Verisurf's CAD software, MSI is able to locate components and create contours and profiles without the need of old tooling. Since implementing this system, the dimensional conformity of the engine ducts is much more consistent, and they have not had one quality defect on the fit. It has been such a successful program that MSI was granted a sole source supplier contract for these ducts to the Air Force. This unique process that MSI developed allows veteran sheet metal technicians to combine the old art of sheet metal fabrication, building and shaping parts by hand, with the advanced technology of the FaroArm. This process shows them in real time where all of the profiles, trim lines, and attach points are supposed to be. It is a marriage of archaic hand sheet metal aluminum fabrication techniques and new CAD/CAM technology.
Everyone here at Mission Support is very excited about the future of this program. CAD/CAM technology has made a huge impact in manufacturing and machining in this country, and because of projects like this, we think it has a great future and will lower costs and improve quality in aircraft structural overhaul.
After production rebuilds the ducts, MSI's quality assurance then inspects the ducts using the Faro arm. Each serialized engine duct receives a generated report for all of the critical attach points and profiles, and this report is used to demonstrate their acceptance to the government QAR representative as a final validation of its dimensional conformance. The first article engine ducts built using the Faro arm were tested on the wings of several B-52s at Barksdale Air Force Base. All the attach points and profiles fit correctly to each aircraft frame, making it an immediate success. For MSI, the Faro arm has improved the consistency of their product and its overall quality. The greater ease of production and inspection, and the greater accuracy with which they can produce and inspect products has been a tremendous value, not to mention the high degree of customer satisfaction, since they now have solved problems that were previously very difficult. What used to take production weeks to locate and profile components on these ducts now takes merely days. It is difficult to calculate precisely, but with the reduced production hours to overhaul these ducts, MSI estimates the savings could possibly be as high as $100,000 over the life of their B-52 overhaul contract. Todd Atterbury, who works as a project manager for Mission Support, knows the importance of implementing cutting-edge technology in their daily routine.
As a mechanic 25 years ago, fresh on the floor, I was always wondering, studying the older mechanics on the floor who've been out there for years and been doing the job. And one time I heard one of them say, you know what makes a good mechanic is knowing the right tools and knowing when to use them. And I held that to heart for several years, going through my career. And then I got to a point where I realized what it takes to make a great mechanic. A great mechanic knows when the right tools are and when to use them, and he's looking for better tools to do the job that aren't available yet. And what Mission Support has done by incorporating the Faro arm into their structural assembly technology is they've made a great process. They make great mechanics out of good mechanics by enabling them to use this Faro arm as another tool in their toolbox.
Due to the success of the B-52 bypass engine duct program using the CAD/CAM system and the Faro arm, MSI is anticipating the receipt of a new government contract from the Air Force for the A-10 Warthog program.
Yeah, the B-52 duct program was very successful for us and for the Air Force. And the Air Force has put a lot of trust in us because of this. They have a lot of confidence in our ability to do it. You know, again, they've made this contract sole source for us. They're coming back with another program for the A-10 where we're going to use the same kind of virtual tooling process. We're going to be working with an overhaul contract, possibly with them, as well as teaching them how to use the same kind of process as well.
This kind of reverse engineering and flexibility in the manipulation of nominal dimensional targets can only be accomplished in a digital CAD/CAM environment, and is a field in which Mission Support is proving to be both an innovator and an industry leader.